Hello and welcome to this tutorial. Today I'm going to show you how you can check for the adequacy of your bolts after you have modeled your bolt group in the Steel Bolt Group Analysis module. For this purpose, let's take a look at a simple example. I found my example in the Steel Structural Design for Lateral and Vertical Forces 2nd edition, where I was able to find this in the accessengineeringlibrary.com by McGraw-Hill. So once we scroll down, we can take a look at the table of contents, figures, examples, and resources. We're going to go straight to the examples. And I'm going to choose the bolt group loaded in plane of fitting surface elastic method. I'm just going to go through some of the context here. We want to determine the adequacy of a 3/4 inch diameter A325 bolts in standard holes. These bolts are snug tight and threads are excluded from the shear planes. The W-shaped plate is grade 50 steel and the channel is grade 836 steel. The service load consists of dead load of 4 kips and a live load of 12 kips. Now to save time, I've already modeled this in ClearCalcs. Once you're done modeling this, you want to take a look at the maximum resultant shear force on the bolt. R at the moment is 11,600 pounds, which is 11.6 kips. This value is important to us because we can use this to compare it with the tables that are available in the Steel Construction Manual. Now let's take a look at those tables. The first table that I have here is table 7-1, available shear strength of bolts. Now let's take a look at this in a horizontal direction like this. So we are using an A325 bolt, and our thread condition is excluded from the shear planes, as mentioned in the example. And we are a single shear plane. So for our 3/4 inch bolt, we are at 15 kips for our available shear. When we compare this number to our 11.6, we see that we're lower than this value, so we're good with this table and we're good with our R. Now another table that you should pay attention to is table 7-4, available bearing and tearing strength at bolt holes based on bolt spacing. The first thing that we're going to see here, if you want to go horizontally, we see the hole type, which for us is standard. Now we have to know our bolt spacing. If you scroll down to the end of this table, you see this note here that says spacing indicated is from the center of the hole or slot to the center of the adjacent hole or slot in the line of force. Now I'm going to show you what this actually means. If we go to our applied in plane vertical and moment loads, we're going to see that our applied load, this will be the line of applied load, basically the vertical line here. So let's say this is going to be the bolt that we want to know the spacing from, and this is going to be our adjacent bolt because it's in the line of force. Our spacing then is going to be 3 inches. After that, we want to know the FU of our plate with the plate that we want to know the available bearing of. So this one, if we go back to our example here, we see that we have a channel a 10/25 and a W section 12/65. One of them is grade 50 and the other one is grade 836. Now I'm just going to go with the lower thickness plate here, which right now is because that was our grade, that was our W, we are going to have our FU at 65. And because, again, we're using a 3/4 inch bolt, we're going to use this is going to be our available bearing, which is going to be 58.5. We have to multiply this value by plate thickness, as I have done here. I've chosen to multiply the thickness of 0.39 by our 58.5, which gives us 22.82 kips, which is more than our 11.6 kips that we had here for our maximum resultant shear force. That's it for today. Please let me know if you have any further comments or questions through help@clearcalcs.com. Have a great day. Bye-bye.